Hello, I'm Valerii Lovkin. Being Associate Professor of Software Tools Department, I represent National University Zaporizhzhia Polytechnic. I am grateful to the organizing committee of the conference for the possibility to introduce the results of my study. The title of my work is Air Pollution Forecasting by Leveraging Traffic Modeling Techniques. As you see here, the first part of my investigation is aimed at problem overview, having the main idea of the investigation as its result. The second part represents the proposed model, data analysis, and experimental results. Air pollution has significant negative impact on human health. There are different air pollutants with the main set containing particulate matters, nitrogen dioxide, ozone, sulfur dioxide, carbon monoxide. Nitrogen dioxide is one of the main air pollutants regarding impact on human health, particularly in developed countries. The study is aimed at short-term forecasting of concentration of nitrogen dioxide. The World Health Organization defines its average level over 24 hours, which is critical for human health, at 10 nanograms per cubic meter. Decisions in short term require accurate forecasting, being more sensitive for changes in concentration of nitrogen dioxide. It is known that not only architecture focused in models impacts on accuracy of obtained results, but input feature set as well. At the same time, one of the main causes of nitrogen dioxide is traffic. Vehicle emissions increase concentration of nitrogen dioxide in the air. There is a range of investigations on air pollution. Long short-term memory, or simply LSTM models, are prior to other focused-in models. But these models mainly use previous values of nitrogen dioxide concentration as input features. You see turquoise markers for them. Darker markers, these ones, represent papers where values of traffic are used as additional input features for forecasting. But these values are defined for the previous period. The investigation is an attempt to use values of traffic on forecast horizon instead of historic time horizon as input features for forecasting models. It is necessary to check if it makes forecasting models more accurate or not. The approach proposed in my work defines corresponding forecasting model. Forecasting is performed for target hours. The problem of forecasting air pollution by nitrogen dioxide is a problem of time series forecasting. It was considered under constraints when not every air pollution measurement station has possibilities to measure traffic flow as well. And at the same time, system of measurement stations of traffic and air pollutants does not cover all corresponding city structure. If a set of air pollution measurement stations is given, then a separate model should be created and trained for each station. Each station is defined to measure concentration of nitrogen dioxide in the air at a certain place. So it is obvious that values presenting concentration of nitrogen dioxide should be measured on historic time horizon and use as input features for a forecasting model. This is the first part of input features of the proposed model. The second part is defined by traffic. As the problem is considered under constraints, traffic and air pollution by nitrogen dioxide can be measured at different places. And that's why it is necessary to define a way to get input features presenting traffic for a forecasting model. In this study, it was proposed to use feature selection method based on decision tree ensembles created by random forest method. It allows to get the most appropriate traffic measurement stations for each air pollution measurement station. The main idea is to select a subset of traffic measurement stations with the biggest impact on concentration of nitrogen dioxide at certain station based on the historic dataset. When this dataset is selected, forecasted values of traffic for the next hours should be used. These hours are the same as target hours. as values of traffic on focused horizon are not known for sure at the moment of focused-in air pollution. Method for traffic focusing should be applied. I applied bidirectional LSTM models with input features presenting traffic values on historic horizon at forecast station and selecting stations as well. For experimental investigation, I used data collected in Madrid, Spain, over a period from January the 1st, 2019 until September the 30th, 2022, and presented in open access at Open Data Portal of Madrid City Council. Hourly levels of air pollution by nitrogen dioxide at 3 different stations in Madrid over the periods of 3 days are presented in figures 1 and 2. These figures display some time patterns for dynamics of air pollution by nitrogen dioxide, but at the same time these patterns are not static, and certain values for different stations could be closer to each other, as you see in the first figure, or more distance, as the second figure reveals. Patterns presented in the third figure display that concentration of nitrogen dioxide at the same station is varied through days and hours. Different days are marked with corresponding colors. As you see, parts A and B represent different stations. The figure clearly shows that concentration of nitrogen dioxide is lower at the weekend, but it is obviously that it's not static through working days as well. At the same time, surges of concentration are possible at night, despite general trend for lower values at night. These different trends additionally emphasize that a thorough analysis of factors impacting on nitrogen dioxide concentration is demanded. My experimental investigation compares LSTM models with different input features. The first variant, which you see in the first row of the table, uses only values of air pollution by nitrogen dioxide for the previous hours. The second variant adds traffic values for the previous hours. The third variant is a result of the proposed approach application. 2 indicators were used for evaluation of the results, mean absolute error and mean squared error. The proposed approach improved mean absolute error of the first variant by 5%, having the best results with low levels of both indicators in comparison with all alternative models. On average, the proposed approach improved mean squared error of the first variant by 6.37%, which is higher than 1.35% of the second variant. Air pollution by nitrogen dioxide is connected to traffic activity in urban environments, but only some existing papers consider traffic values as additional features for air pollution forecasting. But that is why forecasting of air pollution caused by nitrogen dioxide was investigated in my work, emphasizing the role of traffic data. But a new approach was proposed. The idea is to apply results of traffic modeling techniques as inputs to forecast level of air pollution by nitrogen dioxide. These additional inputs are forecasted values instead of historic values used in the known studies. The proposed approach is valuable as it allows to increase forecast accuracy. At the same time, accurate forecasts of air pollution by nitrogen dioxide are critical for decision making. As more complex architectures of deep learning models are promising for air pollution forecasting, it is necessary to apply the results of traffic modeling techniques to such architectures in the following investigations. Thank you for your attention.